Hello everyone, in today's video we're going to be doing factoring monomials. Well, we're going to be factoring polynomials by finding the greatest common monomial. Basically, this is the real math version of GCF, greatest common factor, which you learned when you were doing fractions and multiplication tables and things. Okay, so this is actually something that's super important and it's not that difficult as long as you remember how to do it. So what we're going to do is we're going to draw an open and closed parentheses. We're going to change this question to number 1. We're going to change 28x squared minus 7x. And we're going to change it so that we write, instead of having the exact same thing, we're going to take anything that they have in common, any common factors that's both on the first term and on the second term. We're going to take what's in common between them. Well, they both have an x. The first one has x squared. The second term only has x. Since they both have at least one x in common, I can write a single x outside of that parentheses. What else do they have in common? The first one's a 28. The second one is a 7. 7 is a prime number, so 7 can't be divided by anything. So they don't have like a 2 or a 3 or a 4 in common. So 7 can't change, but this 28 breaks down to be 7 times 4. So 28 does have a 7 built into it. So now that I can have a 7 here and a 7 here, I can write that they have a common factor of 7 on the outside of the parentheses. Then, once we found out what they have in common, we have to write inside the parentheses, what do I need to multiply 7x by to get 28x squared? What times 7 makes 28? Well, I just drew the factor tree and it was 4. Then what times x would make x squared? And that would be an x. 7x times 4x would make the number 28x squared, which we started out with. Then we have to find out 7x times what needs to go here, what needs to fill up the rest of this parentheses, so that we get a negative 7x back. 7x times what number makes negative 7x? Well, it's going to stay exactly the same, so we're just going to put a 1, but we need it to be negative, so it's a negative 1. And we can erase all these underlines. The greatest common factor between 28x squared and negative 7x are 7 and x. So we can pull those out. We can take them off to the side, and these things are equivalent. So don't forget to write that equal sign. Now, 12x squared plus 48x squared times y. How could we grab something? How can we grab a factor that's in common to both of these things so that it just looks a little different but is equivalent? 12 has the number 12. 48 can break down into 4 times 12. So in common between the first term and this second value that we have is a 12. That is the greatest common factor. And 12 times 4, put it in the wrong spot. 12 times 4 would get us back to 48. So I know that I need a plus 4 on the second term. 12 times what? Before I figure out what goes exactly right here, I need to find what else is in common. They both have an x squared. So since both terms have an x squared, I can take that, instead of writing it inside the parentheses, I can write it outside. This is everything that they have in common, the first number and the second number. What would 12x squared need to multiply on the inside to make 12x squared, to make what it started out with? It would only need to multiply the number 1. Then, what would 12x squared need to multiply to make 48x squared y? I already wrote the number 4, so 12 times 4 would make the 48. X squared times nothing gives you already to x squared. But then how do you get that y to show up? If it's not outside the parentheses, then that y must be still inside of the parentheses. In this example, let me just go ahead and show you that these two things, the left side and the right side, are equivalent. If I multiplied 12x squared times 1, that would make 12x squared. If I multiplied 12x squared times 4y, it's going to have a plus sign. 12 times 4 makes 48. X squared and y are different letters. They're different variables, so we can't combine them, but we can just write them both next to each other, which means they're multiplying. And now you can see that what I have in orange is the exact same thing as what we started with. The point of this is that, like how in a lot of other lessons I've taught, there's multiple ways to do something. Factoring just shows a different way you could look at certain numbers. It's a different perspective. I'll do a couple more with you. Let's go to number 7. I have 21mn, 28 m squared n squared, 35 m cubed n cubed. Okay, so this one has 3 m's, this has 3 m's, this has 2 n's, this has 1 m. That means that the only m I can factor out of all 3 of these, I can only take a single one that's in common to all 3. And since I have 3 terms, I'm going to draw my parentheses a bit farther apart. I don't know if I'll really need it that far, but that's just my placeholders right now. What else do these numbers have in common? What about the coefficients? 21, 28, 35. Those are actually all multiples of 7. So I could take out a 7, and 7 times, well, 7 does fit into 21, 7 fits into 28, and 7 fits into 35. I don't think that there's something greater than 7, but if it turns out there is, we'll see what happens if there's more. But I don't think there will be. Then for the n's, those are all the same powers as the m, so it's still going to be a single n. Now we just need to see 7mn times what value would make the 21mn. 7 times what makes 21? It's going to be a 3. mn times what makes mn? It's going to be the number 1. It doesn't change at all, so we're not going to put any mn's inside there. We'll just put the plus sign. 7 times what makes 28? It's 4. mn times what makes m squared n squared? We'll need one more. And if you multiplied this times that, the powers would add. The powers would add to make that squared. Finally, we have the last term. 7 times what makes 35? It's a 5. And to get from a single m to m cubed, we need m squared inside, and we will also need an n squared inside. And look, I didn't put enough room. I got to move that parentheses a little bit more to the right. So then all of that top part is 21mn plus 28m squared n squared plus 35m cubed n cubed is equal to 7mn plus 7mn times 3 plus 4mn plus 5m squared n squared. Close the parentheses. Let me find another fun one. Let's do 20. 20. I have a 3, a 30, and a 75. 3 and 30 obviously have a 3 that they can fit inside them, that are a common factor. 75, if you mess around with change, that's 3 times 25. So 3 is in common to all of those numbers. Now let's see how many x's there are. The first one has x cubed, which means 3. The second one has x squared, which means 2. The last one only has 1. Since this one only has 1, I can only take out a single x from all of these. 3x times what makes 3x cubed? 3x times x squared. If I multiplied these two values, I would get back that 3x cubed. we need to copy a plus sign. 3x times what would make 30x squared? It would be a 10x. And finally, what times 3x would make 75x? If we took the 3 from right there, then this 25 is going to be what stays inside. And it's going to be negative, and there will not be an x on that 25. It looks like we have the greatest common factor between all three things, but if you wanted to, you could open up another set of parentheses to find the greatest common factor between these two, the x squared and the 10x. Or alternatively, you could open up a parentheses around these two, and they have something in common, and that would be a factor of 5. I'm not going to make you do either one of those things because the question doesn't want you to. It just asked for the greatest common factor. It didn't ask for the greatest common factor and then find the greatest common factor of the next thing. But in tomorrow's video or Monday's video, you'll see how you can factor this in a cool way.